In today's video, we're going to talk about practice problems for MTE 3 Algebra Basics. First problem is to find the absolute value of -3. The absolute value is the function that gives us the distance away from 0 on the number line. So if we look at -3 on the number line, it's 1, 2, 3 units away from 0. We're always going to be looking for the magnitude of the number, not the direction of the number. So ignore the direction, ignore the sign, and look at the magnitude of the number. The absolute value of -3 is 3. For number 2, it asks us the absolute value of 18. Well, that's 18 units away from 0 in the positive direction. 18 is over here somewhere on the number line that we would have to travel 18 units to the right to get to it. Number 3 asks us to write 13 times 13 times 13 in exponential form. That's going to be 13 to the third power. 4 asks us to write 1 times 1 times 1 times 1 times 1 in exponential form. Okay, that is 1 to the 5th, but since 1 to any power is 1, we can just write 1. And that's a simplified form because there's no difference between 1 to the 5th and 1 to the 1st. They're both 1. Number 5 asks us to evaluate 2 to the 3rd, which is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. You should start at this point to memorize your perfect squares and perfect cubes. We're going to need them later in algebra. So start working on that. Evaluate 4 squared. 4 squared is 4 times 4, which is 16. It's one of those perfect squares you should memorize. Why do you need to know perfect squares? Because you need to be able to answer things like this. What's the square root of 16? Well, we just saw that 4 squared was 16, so the square root of 16 should be 4 because this is the square root of 4 squared. So the squared and the square root cancel each other out and get left with 4. I can only take square roots of non-negative numbers. Be careful with that. We're going to talk about that more when we get to MTE 8 material. Now we want to follow the order of operations 6 plus a -10. When I add a negative number, that's the same thing as subtraction. But I'm just going to rethink this with commutative property of addition, that that's -10 plus 6. So since the bigger number is negative, I find the difference between 10 and 6 is 4, and I keep the sign of the bigger number. The answer is -4. If I draw that on a number line, I'm going to start at -10, and I'm going to move 6 to the right. And I'm going to get to -4. It's -9, -8, -7, -6, -5, -4. 0 is over here. Number 9 asked me to perform the indicated operation 1/8 minus a -4/3. Well, that's going to be when I subtract a negative, that's the same thing as addition. Now I'm going to have to make a common denominator, which is going to be multiplying this one by 3/3 and this one by 8/8 to get 3 plus 32/24 is 35/24. Nothing in common. I can leave that as an improper fraction. If I want to change it to a mixed number, I can. That would be 1 and 11/24. No reason to change it to a mixed number, but we can if we want to. All right. Number 10 asks us to multiply -7 times -3 and a tenth. So that's going to be 21 and 7/10. A negative times a negative is a positive. Next, we want -72 divided by -9. Again, a negative divided by a negative is a positive. 72 divided by 9 is 8. Our next problem asks us the opposite of 4 squared plus 6. Exponents come before multiplication before addition. So this is -16 plus 6 is a -10. This is not the same thing as -4 quantity squared plus 6, because this would be a negative times a negative is a positive, but it didn't ask us to do that. The negative is not part of what's being squared. We square first and then find the opposite of it and then add 6. -5 plus a -10 minus a -4 minus 13. This is -5 minus 10 plus 4 minus 13. Addition and subtraction happen at the same time, left to right. So I'm just going to take the first two. We're going to be -15 plus 4 minus 13. This is going to be -11 minus 13 is a -24. Next, we have -32 minus 8 divided by 4 minus a -2. Okay, so we don't have anything in parentheses to be done. This division comes first. I take the entire -8 divided by 4 is going to give me it's going to give me a -2. It'll be plus a -2, which is subtract 2. I also have minus a -2 here. That division happened first. Now this multiplication happens. Addition and subtraction can happen in any order from left to right. That's plus a negative. So this is going to be this -2 plus that 2. Those are opposites that add to give me 0. I should be left with a -32. Number 15 asks us to add 2 plus the square root of 4 times 10 minus 2 in parentheses plus 3 squared. Parentheses come first. Then come any roots or exponents from left to right. These aren't touching each other, so I can do them at the same time. Now comes the multiplication. Now comes all the addition. 11 plus 16 is 27. We're going to look at 10 to the -3rd, and we're going to write it as a decimal. That's the same thing as 1 over 10 to the 3rd, or 1 over 1,000, which is the same thing as 1,000 as a decimal, like that. Now we're going to write a big number in scientific notation, 2,061,000,000. This can be 2 and 61 thousandths times 10 to the, I move the decimal place 3, 6, 9 times. See that? If I put the decimal place where this comma is, so there's one number to the left of the decimal point, then I'm going to have to move the decimal points 3, 6, 9 times to get back to my original times 10 to the 9th here. Now we're going to take something that's written in scientific notation, 9 3/10 times 10 to the -2nd. We're going to move that decimal place to the left 2 place values, and we get 93 thousandths. Take a second here to talk about some properties of real numbers. You scroll here so you can see these a little bit better. So in 19 part A, we have 3n plus 5 equals 5 plus 3n. That's going to be the commutative property of addition. Commutative properties mean that I can change the order of things, can move them around, and it doesn't change the answer. Our second rule there is going to be changing the grouping symbols on things that have equal precedent. So everything there is addition. I can add the second and third term first and then the first term, or I can add the first and second term and then the third term. It doesn't matter. So that's called the associative property of addition. part C is going to be the distributive property. Distributive property. That's where I distribute one number over a set of parentheses because it had been factored out front. We're going to talk more about factoring in MTE 6, but for right now, A is what's called a greatest common factor. It was factored out because it was a common factor of A, B, and AC. So we factored it out front. When we undo that, that's called the distributive property, right? B plus negative B equals 0. That's called the additive inverse. Okay, so B and negative B are additive inverses that add together to give me my additive identity, which is 0, which is what the next property is that I can add 0 to anything and not change it. That's called the additive identity. The identity happens where I do not change the value on the left and the right. I add something or I multiply by something that doesn't change anything. The multiplicative identity is the next one. I can multiply by 1 and not change the value. So that's the multiplicative identity. And the last one, G, is going to be the multiplicative inverse. We have a special name for that we're going to call the reciprocal. I use that word later. It's shorter, so I like to write that. But we usually denote the multiplicative inverse or the reciprocal with an exponent of -1. So anything times its reciprocal here is going to be equal to 1. We're going to use that notation though with a -1 later in math to mean the inverse of something in general. So it's not always a multiplicative inverse when you see that symbol. All right, number 20. Ask us to combine like terms to simplify. 19n plus 30b minus 9b plus 4n. So I'm going to have to get the like things together. 19n and 4n are together. 30b and 9b are together because I add n's to n's. 19 plus 4 is 23n. 30 minus 9 is 21b. 21 asks me to simplify completely 5 plus 3 times x minus 1. This instruction that says simplify means to do the order of operations. Notice I don't have an equal sign when I get an instruction that says simplify. It's just a statement. It's not an equation. So I'm going to use my distributive property here. Since I can't do anything on the inside of the parentheses, I'm going to distribute 3 over them. And now I have 3x plus 5 minus 3 is going to be 3x plus 2. Number 22 asks me to evaluate, that means find the value of this statement when x is equal to 5. So first we start off with x squared plus 2x minus 1, and we're told that x is equal to -5. So we're going to replace all of the x's with -5s in parentheses. That's important because -5 times -5 is going to be a positive 25. Well, a positive 2 times a -5 is a -10. So this is going to be 25 minus 10 is 15. 15 minus 1 is 14. '23 asks us to evaluate the formula for the area of a trapezoid, an isosceles trapezoid. These sides are the same. You've got a little b, you've got a big B, you've got an H. This is how you would find the area of that isosceles trapezoid. So they tell us that they want us to find A when H is 10, big B is 20, little b is 16. Okay, so that's going to be 1/2 of 10 and times 36. It doesn't matter which number I take half of whichever one is even. They're both even. So let's take half of 36 is 18 because it's really easy to multiply by 10. 18 times 10 is 180. This is going to be square units. They didn't tell us what the units were. I know area has to be measured in square units. 24 asks us to solve. Notice how the instructions changed and they don't say simplify anymore. They say solve because there's an equal sign in the problem now. So we're going to have to get all of our letters that we're solving for on one side by themselves. Then we're going to use inverse operations to get all of the numbers away from the letter that we want to solve for. In this case, we have a +7 attached to our letter we want to solve for. So we're going to subtract 7 from both sides because addition and subtraction are inverse operations. That leaves me with n by itself. -16 minus 7 is a -23. Moving right along here, we've got 25. Asks us to solve -2/3 plus x is equal to -1/6. So I'm going to have to add 2/3 to both sides. When I do that, I have to make a common denominator here. So this is -1/6 plus 4/6, right? So that's going to be 4 minus 1 is going to be 3/6, which is the same thing as 1/2. So x is equal to 1/2. You're allowed to express your answer in a decimal if you want to. No problem with that. Since we've done both fractions and decimals, it would be just as appropriate to say that that's 5/10. We just like fractions better because you can express answers exactly as fractions a lot easier than you can express them exactly as a decimal. -8x is equal to -72, so we're going to divide both sides by -8. When we do that, a negative divided by a negative is a positive. 72 divided by 8 is going to be 9. 27 asks us to solve -2 and 4/10 plus t is equal to 5 and 6/10. So we're going to add 2 and 4/10 to both sides. And when we do that, t is going to be equal to 8. It's 8 and 0/10. I don't need the 0/10 anymore. So let's give ourselves a little bit more room. Move on to problem number 28. To obtain her bachelor's degree in nursing, Judy must complete 130 credit hours of instruction. She has completed 60% of her requirement. How many credit hours did Judy complete? 60% of 130 is what? That's the question. So 60% of means to multiply. 130 is my equal sign. X is my variable when I'm going to solve like this. So this is going to be divide by 10 here. It's going to be 6. Divide by 10 here is going to be 13. X is going to be 13 times 6 is going to be 18. 6 and 1 is 7. So she's completed 78 credit hours. Number 29 says factory manufacturing low voltage relays found 4 defective relays and a lot of 80 relays. At this rate, how many defective relays can be expected? And a lot of 740 relays. So this is a proportion that the defectives over the total in the lot should equal the defectives over the total number in the lot. Let's reduce because 4 goes into 80 evenly. So 1 over 20 is equal to x over 740. To solve for x, I need to multiply both sides by 740. So x is going to be 740 divided by 20. Divide both by 10. 2 goes into 74 37 times. I should expect to observe 37 defective relays in that big batch of 740 relays. The population of Lewisburg was 10,820. It decreased by 320 each year for 5 years. What is the population after 5 years? So I'll call P for population. P is going to be 10,820 minus 1,600. 0 minus 0 is 0. 2 minus 0 is 2. 8 minus 6 is 2. 10 minus 1 is 9. The new population should be 9,220. Problem number 31 asks us to find the volume of this rectangular prism that's it looks like it's 8 feet long, 6 feet wide, 4 feet tall, right? So this is 8 feet long by 6 feet wide by 4 feet tall height. So this is going to be let's do 32 times 6. 32 times 6 is 12, 18, 19, that's 192. Look at your units here, feet times feet are cubic feet. So that's my volume. It's going to be 192 cubic feet. Part B asked me for the perimeter of the floor. So the floor down here is, as we look at it, is 8 feet. By 6 feet. So we're going to have 2 times 8 plus 2 times 6 is going to be 16 plus 12 is going to be 28 feet. Part C asked me for the area of the floor, which is going to be 6 feet times 8 feet. It's going to give me 48 square feet. All right, that's all the practice problems for MTE 3. See you next time for our MTE 4 practice problems.